And this is how we're going to word it. A to the m times a to the n. The a's represent you have the same base. It could be a variable, it could be a number. But what you can do with those exponents is add them together. And it might not make sense until we put another example in there. So let's go one right here. If you have, let's use m from us, m squared times m cubed, you have 2 here, you have 3 here, for a nice total of how many, Mr. Moss?
5.
5. And we write that as m to the 5th. Now, if you're ever not sure what the rule is, though, you can go back and you can physically write, just like I was showing with my fingers there. You have 2 here, and you have 3 here, for a nice total of how many m's. You can see the 5 physically written out. Okay? All right, rule number 2. If you have anything, any exponent raised to another exponent, you know how we talk about that parentheses means what operation?
Times.
Multiplication, good. That's exactly what I want you to think about. It's not exactly accurate right there, but if it helps you think about that it should be multiplication, that's what you could do with the exponents. So let me show you that example right there. This time I'm going to use b squared raised to the 3rd. And our operation says we can just multiply those together. 2 times 3 is?
6.
Good. Now, if you're ever not sure about that rule, here's what you can do again. This thing with the 3 means you can write this out how many times?
3.
3 times. So let's do that. B squared, B squared, B squared. And then how many times can you write out each of the b's?
3.
Well, how many on this one?
2.
2. So BB, BBB, BB. How many do you see there?
6.
Okay. So if we have different things inside of parentheses raised to an exponent, I want to be careful on how I use this word, but you are going to distribute the exponent to all items. And I'm saying distribute because we know that this is not distribution, right?
A to the m times b to the m.
Exactly, well said, Mr. Moss. And that includes if you have a number in there.
Okay.
So let's show a couple examples. Let's do x squared and y raised to the 5th. You see you have 2 different variables in there. You're going to take it through twice. Now, this rule goes back to here, right? You have an exponent raised to another exponent. You're just going to multiply them together. Good. So x to the
10th and y to the 5th.
Well said. In practicing, this is where we can use. Okay, so we have 2 to the 4th, we said was 16, and Mr. Moss, you said this one is going to be a to the what?
12.
Excellent. So make sure you do raise your coefficient. If you're dividing and it's raised to an exponent, it's the same thing. Everything gets an exponent. You're going to take a to the m, and you're going to take b to the m. Let's go ahead and show an example.
Wait. 27.
Good. And Mr. Black, what is 5 cubed?
120.
120.
What? 125.
Good attitude.
Nice.
Okay, the next rule I want to talk about is if you have, just like this one, we had 2 same bases multiplied. If you have 2 same bases divided. And you've probably done this rule before. Do you remember this one at all?
I remember last year.
Probably looks a little funny with the A's in there. Let me show you a different example. X to the 5th over x to the 3rd. What would we do in that circumstance?
It would be x to the 5/3.
Maybe we should write it out. That this is how many x's up top? How many did we write out?
5.
5.
Oh, I actually it would be
And 3 on
x
the bottom.
squared.
Yeah, we're going to cross these off and we're going to get x squared. How do you get a 2 from a 5 and a 3?
You subtract.
That's exactly right. This is where you subtract your exponents. Okay, so the rule is that you can subtract your exponents. Now, what I also want to state in this rule that you don't get in your book, so this is important, is that I subtracted from this top guy, right?
The one that's being divided.
The one that's they're both, yeah, it's being divided. And in that case, I have nothing left in the bottom, because this crosses off, right?
Oh.
Okay, however, I don't have to do it like that. I can subtract from the bottom, but if I subtract from the bottom, the answer needs to stay in the bottom. So if nothing's left up top, the 1 stays up top this time, and it's a to the n minus m.
So it'd be the same thing?
It will be the same
It'd
thing.
just be the reciprocal.
I want to be careful with that. Not exactly. So let me show you some
Oh,
examples.
it'd be the negative.
So let me show you this, back to this one. I would choose to subtract from the top, and I do 5 minus 3 to get 2 over here.
Oh, so you
Right.
do like the bigger number so it's not negative.
Correct. So let's do one more where it looks top heavy, or bottom heavy. So we would do m to the 2nd all over m to the 8th.
Ooh.
So you see how the 8 is bigger?
Yes.
So I want to subtract from the bottom. So 8 minus 2 is, Mr. Mouse?
8 minus 2 is 6.
Good, and we completely took that one away. There's nothing left at top. This would be 1 over m to the 6th. Now, what would change about this problem right here if I put a 4 in the front?
Excuse the interruption. At this time, I need boys B basketball to go to the top of the hill, and the siblings of those children, please, to as well go up to the top of the hill unless other arrangements have been made. Britt and Ellie Stibley, please go to the top of the hill to meet your mother to go for basketball. Thank you and good luck.
You subtract from the top and take away 1. There you get a 4.
Okay,
Wait,
so
what?
is this attached to the 4?
No.
Yes.
So, no, it's not. It's only attached to the m, right? So that's the only thing it affects. So what's going to be in our answer?
Oh, it's going to be 4 over n.
Correct. So if you have a number up there, leave it up there. It doesn't affect it. Now, what if I put in the bottom now, what if I put 12 down there? Now look at my numbers. This is a regular fraction.
You subtract.
Oh, regular fraction.
Oh, you.
Regular fraction, Mr. Black.
It'd be 3.
What would be 3? Get specific. Where is the 3?
Bottom.
Bottom.
Bottom. So 4 goes into 12 3
denominator.
times, and it goes 3. Nothing left at top, and it changes to 1 again. All right, so again, if you have coefficients, you reduce them like a regular fraction.
Huh.
Okay.
Okay, number 6.
Yay, 6th rule.
We learned this one a while ago. A to the 0th power will always equal
1.
1. Okay, so when we learn this, we learn to really look for what is the 0 attached to. So if I said 5 to the 0th, you are going to tell me the answer is
1.
1. Now, look carefully. I'm saying opposite of 5 to the 0th. What is, and I just changed the problem a little bit.
-1.
What is it attached to? Still just the
5.
5.
-1.
So it's negative.
-1. Excellent. Now I'm going to change it again. I'm going to put parentheses this time. What is the 0 attached to?
The 5.
The -5.
Yeah, it's
Oh.
attached to everything. Okay, so what does our answer become again?
1.
1. This time I'm going to change it and I'm going to put a 2 in front. What is the 0 attached to?
Negative 5.
Still just the -5. That part's 1. What operation's in between right there? If you can't see it, multiplication. Perfect. So that's saying 2 times 1 is 2. Nicely done. Now let's talk about why this rule is true. We talked about it a little bit at the beginning of the year. Let me give you an example like 5 divided by 5.
1.
Do we agree that this answer is 1?
Yeah.
Oh.
Yeah. What are the invisible exponents on each of those 5s?
0.
Mm-mm.
They are
If they'd be
ones.
0, then they'd be 1 over 1, right?
They are 1.
They are 1s. This is a 1 right here, this is a 1 right here. Okay, now, go back to this rule. What can we do when we're dividing? We can do what with their exponents?
Subtract them.
Subtract them. 1 minus 1 is?
0.
Okay. So 5 to the 0th is still 1. Next, in rule number 5, we talked about how to avoid getting a negative exponent, but sometimes you can't avoid it. So let's talk about negative exponents and what we're going to do.
7.
Now I'm going to skip this part and I'm going to do an example, then we're going to come back. Number 7. Okay. Or x to the negative 3. Okay, look carefully. What is the negative 3 attached to?
Yes.
Just the x, just this, right? 4 is going to stay. What we are going to do with the negative exponent, if it's in the top, we are going to flip it to the denominator of the fraction. So our answer, we're not going to touch the 4, he stays in the top, and we're going to flip and become a positive x cubed, or I should say x to the positive 3. When it flips, it changes.
We don't know that, so it would be a.
So you're making fractions.
So it
We're
would
making a fraction, and this works vice versa. So if I have 2 over m to the negative 4th,
you would flip it.
we're going to take it from the bottom and put it in the
Top.
and we're going to leave the 2 in the top, so it's 2m to the 4th.
Yes, so the rule would be okay.
One more thing before you get to the rule. What if I took this away and I said 1 right there? What number goes in front?
1.
A 1
Or nothing.
or nothing. Exactly. And so that's what I want to get across when I write down this rule. If we have a to the negative m, what number's right here in front?
1.
1. Okay, so when we flip it, 1 stays up top and becomes a to the positive m.
Okay.
And vice versa, if we have 1 over a to the negative m, it flips and becomes 1a to the positive m, or just a to the m. Negative 72, good. 1m here, 3 m's here for a total of,
4 inch.
okay, and we write that as m to the 4. Go on to the ends. 2
N to
ends
the
here, 6 over here for a total of,
N to the 8.
okay, there's your answer.
That was easy.
Yeah, you said 7 goes into 21 how many times?
3.
3 times, okay. So 3 stays in the bottom. What happens with this x squared and x squared?
They cross out.
Cross off, good. Look at the y's. Which exponent is bigger?
Top.
Top, so we're going to subtract from the
Bottom.
top. If it's
Top.
bigger in top, subtract from there. So 6 minus 3 is
3.
3, and that stays up top.
I did the third.
Z is by itself, but is there any
Please.
matching?
No.
No, so we're going to leave that.
So
here
why
we go.
did the third
Three.
over 3 is E?
Yes. Okay. I do want to do one more, please, so don't pack up yet.
Over.
Okay.
Multiply those exponents.
Okay, so you're saying take the 5 and take it through each
Yeah.
item.
Distribute.
Sure, you can do that
That's
one
what I
first.
did.
All right, now be careful here. This is negative 2 to the 5th. Concentrate. What is 2 raised to the 5th?
Negative 10.
No.
No.
No, negative 32.
32. Now, since this is a negative odd exponent, your final answer is going to be a
Negative.
negative. So negative 32. M to the,
30. And to the
I heard it, 3 times 5,
15.
15. And n to the negative 2 times 5,
10.
10.
positive or negative?
Negative.
Negative 10. Now, there's one more thing that has to be done on this problem.